Are you able to see my screen?
Yes.
Okay, great. So today I'll be talking about some solutions for the golden mussel crisis. I'm sure we're all very familiar with the crisis itself. And the approach that SePRO takes is creating a plan first. So looking at your system holistically before we even start talking about which product or solution to choose. So we do this through a three-step process consisting of an assessment phase, a prescription phase, and finally an implementation phase. Part of the assessment phase is simply understanding what is going on in your system. And I'm sure that Dudek can speak more to this today. There are several consultants out there that can assist you with this assessment phase. But we basically want to assess what life stages you have present because that will guide the rates of treatment that we're using. We also want to understand the use sites. Where's the water going after we're treating it, or where is it coming from? Understanding your water flow. Is it variable or very consistent? Does it turn off at all? The water chemistry is extremely important as well. If we have a high bioload, lots of algae, lots of total suspended solids in there, that will impact how our chemistry is going to work. The management timing is also extremely important. If we're treating when water is cooler, then we might need longer exposure times or higher exposures of the active ingredient in general. Or during warmer months, we've seen that lower exposure rates and times can be effective. And lastly, the product storage capacity and logistical needs. We've all run into logistical issues on projects before, so really tackling those before we start talking about how we'll put it in the water is very important. So then we get into the prescription phase, and there are two options available through SePRO right now. One is Matrix CA. This is a chelated copper product. It's copper ethanolamine complex, a mixed complex. It has a broad range of use sites, and these chelating agents and the multiple types of chelating agents mean that this product is less interactive with organic matter, so it's less likely to bind to those algae or total suspended solids or anything else in the water, and we're getting more copper actually into the target species in the golden mussel. There are also no water use restrictions. We're always happy to do an assessment on what types of crops you're irrigating, if that is a concern for you, to show that the levels applied are going to be within those limits for those crops, or really any kind of analysis you need to make sure that you understand that this product can be safe for your use site. We can achieve complete mortality of adults with Matrix CA. So adults are the most hardy life stage of the golden mussel. So with complete mortality of adults, we can also achieve complete mortality of the veligers, the larval stage. And through this, we are using customizable concentrations and exposure times. So looking at this graph here, on the y-axis, we have percent mortality going from 0 to 100%. On the x-axis, we have our exposure time. And so if we're using a lower rate, then we might just need a little bit longer exposure versus if we go at a higher rate, we might achieve it in higher exposure time, or excuse me, lower exposure times with the higher rate. But again, a lot of this is temperature dependent. So going back to understanding the water chemistry and temperature is the first step here before developing a prescription. And it's a very dense formulation. So we want to make sure that where we are putting it in the water, especially if it is a flowing system, we have good mixing so that it doesn't all channelize to one side or to the bottom of the flowing water. You may also have heard that SePRO recently acquired Earth Science Laboratories, and so this has also made the EarthCheck QZ formulation available to us for golden mussel control. So this is also a copper-based solution with proven activity against invasive mussels. It's effective for targeted control in water systems and infrastructure. So we're talking about targeted areas of lakes and reservoirs, as well as in flowing water systems like canals and irrigation. We have a very flexible application, very similar to that last graph that I showed you for Matrix CA for both prevention of treating veligers and responding to adult infestations. And lastly, and arguably the most important fact about EarthTech QZ is that it has the NSF certification. So it also has a very broad range of use sites, has no use restrictions, but it has that added layer and support of the NSF certification, which may be important to you if you're treating any kind of drinking water or anywhere where people are sensitive to that NSF requirement. And so lastly, I just want to touch on implementation here a little bit. We may have very complex management systems or requirements. So SePRO Water can help work with you through each step for system configuration, access, getting that correct injection equipment and calibration of that injection equipment. Understanding multi-site management if we have to have several separate injection points on a single system. Monitoring and verification through copper monitoring and confirming bioavailable copper throughout the system. And lastly, any kind of safety and regulatory or permitting restraints or help that you need. So with that, I'll go ahead and turn it over to our next speaker. Thank you.
Okay, everybody see my screen okay?
Yes.
Great. Well, thanks for having me here. My name is Jacob Dutry. I'm with CD3 Systems. CD3 stands for Clean, Drain, Dry, Dispose. And we manufacture waterless cleaning systems that are being placed at boat launches in order to help prevent the spread of aquatic invasive species. So I'm just going to cover some of the operations and different prevention strategies that we employ. Run through how or what and how a CD3 system works, some of those strategies, and then a Stop Sorry project that we did in the state of Minnesota. So right now, I think we're doing a great job of informing the public of what invasive species are. Most people know to clean, drain, dry, and plan to act, but unfortunately fail to take action. And we're finding that having tools at a boat launch is one of the largest limiting factors for watercraft users to be cleaning before or after they launch. So that's kind of where CD3 Systems comes into play. And we'll be the first ones to tell you that we're by no means a silver bullet, but I like to think that we're a piece of the silver buckshot for prevention, in that we have long-term cost effectiveness and have 24/7 availability with self-service equipment, and that it lasts 10 plus years in the field, and high efficacy for the removal of invasives and the habitat that they would need to survive. So again, ultimately, we are free to use waterless cleaning tools that are meant to be placed at a boat launch, generally speaking, within about 200 feet of the launch, and ideally with signs and line delineation guiding people toward using that equipment. So how CD3 system works is first and foremost, we have an educational kiosk on the front of the unit, fully customizable so that you can have the specific calls to action for your area and let people know what the equipment is and how to use it. As far as the removal goes, we have tethered hand tools in the center. These are attached to stainless steel plastic coated cable. So brush, plug wrench, and a grabber tool. And then rather than the water, we use air components. So in the red hose, we have a air blower that puts out 90 PSI air. And that way you can utilize it to spray off anything from the sides of your boat, trailer, fishing or wreck gear, just getting any debris or water off your watercraft. And the blue hose, we have a wet dry vacuum that's used to suck up any water that's standing within your boat still, such as your live well, bilge, and use it to dispose of bait. And then, really just getting any of that habitat out of your watercraft so that you're not potentially transferring anything like alligators that you may not necessarily be able to see. Then we have lights above and below to allow for boaters to see during those low light conditions. And we are fully solar powered, so it makes it easy to be placed at remote locations and anywhere that doesn't necessarily have the infrastructure for power or water hookups. And finally, we're internet connected, so we are able to track the tool use data, and that'll get uploaded to an online portal that you'd be able to access. So it's kind of a good, better, best version. With the wayside, we have a stationary version as well as a trailer version. And then a step down from that is our outpost, which removes the two air components, keeps that cellular connectivity piece of it. And then our smallest unit, the roadside, removes the cellular piece, and software is just a couple of hand tools with some educational signage. Usually these are meant to be most placed at more remote locations or canoe kayak launches. And so again, with that software, this is kind of what that looks like when it gets uploaded onto the portal. Puts everything out onto a nice dashboard for you, and then you're able to pull that off onto Excel spreadsheets if you wanted to use it for different management reports. It also provides maintenance alerts. So with that wet dry vacuum, there's a 110-gallon tank. Once that reaches the 80% capacity, then it'll send out an email notification letting you know that it's time to have that pumped out. So some different strategies with prevention equipment, two biggest ones being shielding and containment, and or both, if your launch allows for it. But shielding being that you are protecting that water body from a new infestation, and containment being that you're containing infestation to a water body so it's not spreading elsewhere. And ideally, I would recommend if you're doing a project like this, following the SOBA standards, the State Organization of Boating Accesses. They have really good guide as far as how to best set up your launch for prevention tools. And again, having that equipment within 200 feet of a boat access, having the signage and line delineation guiding people to using it really goes a long way. So this is kind of real quickly, this is what the SOBA standards looks like. Again, it's pretty straightforward and simple, but having those signs throughout the launch at multiple locations, letting people know that there's cleaning equipment available and that you'd like them to use it before or after they're done launching. And so with that, I will go into a quick project that we did with the state of Minnesota with starry stonewort. And if you're not familiar with starry stonewort, this is a macroalgae. It's a super spreader species as it spreads through fragmentation and these star-shaped bulbils that you see in the image. And this was a relatively new species that was found in Minnesota, but it had the state worried about it spreading to all of their other lakes. And so they wanted to do something about it. And so the Minnesota Lakes and Rivers Advocates in 2014, they had lobbied to access the state lottery funds in order to be put towards their Environmental and Natural Resources Trust Fund for aquatic invasive species prevention. And then they brought us on as the prevention infrastructure piece. And so there was, in total, we've identified 22 lakes, which then have 34 boat launches that have been covered with CD3 equipment in order to contain the starry stonewort to those particular lakes. On the first 2 years of CD3 implementation has seen really great adoption. We had over 50,000 tool uses in the first 2 years and 22,000 individual cleaning sessions, and overall over $1 million funding brought to the area. And most importantly, we're actually bending the curve. So since the aid was brought in 2014, you can see that the number of new infestations per year has started to come down over time. And so with those prevention efforts, it really does show that it can go a long way. And so with that said, now with asking to clean, drain, dry, and people plan to act, they can CD3 because everybody likes a clean boat. And with that, I will leave it to the next one. Thank you.
just go ahead and share my screen. Let's see. Oops. Okay, can everyone see that? Awesome. Wonderful. Okay, all right. Thank you all so much for being here. My name is Valerie. I'm a biologist at Dudek, and so I'm going to talk a little bit about some of the support that we provide to various water managers in response to the recent arrival of the golden mussel. So just to give a super quick background, I'm sure everyone's pretty familiar, so I'll run through this pretty quickly. Golden mussel is a freshwater mussel that's native to China and Southeast Asia. Over time, it spread beyond its native range, reaching South America by the 1990s. In North America, we are more familiar with dry-sanded mussels, so quagga and zebra mussels. Golden mussel is actually within the Mytillidae family, which is a new type of family of invasive mussel, but it carries with it the same concerns that we're familiar with dry-sanded mussels. And this includes filter feeding behavior, which can change or can alter water quality regimes, as well as free spawning behavior, which means they release their gametes directly into the water, which makes it very easy for them to be transported downstream into other water bodies because they do not require a host. They also exhibit attachment to hard surfaces with those strong byssal threads, so they can rapidly colonize any kind of man-made structure that comes into contact with water-containing mussel veligers. What differentiates them from dry-sanded mussels is that they are overall more robust, both in structure, strength, and resistance to traditional mitigation approaches. So some specific impacts that they carry with them are primarily to conveyance infrastructure. So infrastructure that is actually moving water, like channels, piping, intake screens and towers, anything that can potentially inhibit the movement of water with mussels present, as well as operational equipment. And so this is going to be equipment like cooling and bearing water, as well as meters, sensors, and stilling wells. So anything that is required, any kind of instrumentation that is required to maintain operations at your system or facility. They also potentially carry certain ecosystem impacts, including food chain disruption as a result of that filtration behavior, in addition to the increased risk of harmful algal blooms due to that water clarity increase. If we kind of like scale up to the human ecosystem, they also have the potential to create physical hazards due to the sharpness of those shells in a recreational setting, as well as corrosion and damage to recreational equipment like boats. Across the board, all of these potential impacts have a high likelihood to increase overall costs to the facility or water system due to increased maintenance and potential facility retrofits. So golden mussels were first found in the Sacramento-San Joaquin Delta and O'Neill Forebay in October of 2024. This is a particular concern being found in this location because California water is just overall highly connected. We have 75% of water falling or rain falling in the north, with 80% of the need of water in the south. And the State Water Project, which is shown in blue here, as well as the Cross Valley Canal, provides water to 2/3 of Californians down south of the Delta. Along the way, there are 30 pumping or over 30 pumping and hydropower plants that are now at risk due to this connection. And there are also a number of connected canals along the way. So effectively, this system creates almost like a golden mussel superhighway that can convey mussels all the way through the state. And unfortunately, over time, this is exactly what we saw with golden mussel spreading 400 miles south by September of 2025. And then further, we see that east-west expansion by November of 2025 along those many connected canals and channels. So Dudek has been sort of on the front line of the golden mussel invasion due to our work with the California Department of Water Resources. We've sort of been involved since day one, and we are uniquely capable of providing a suite of support services to as they relate to golden mussel management, because we have a highly comprehensive suite of in-house technical experts in different areas of expertise. And so this comprehensive expertise, mainly consisting in this case of biologists, engineers, planners, hydrogeologists, and regulatory specialists, allow us to provide a comprehensive approach to golden mussel management in a variety of areas, including prevention, preparation, as well as invasion response. And so I'm just going to go through some examples of the areas that we have supported golden mussel response in these areas since they've arrived. So in terms of prevention, we're thinking about trying to avoid getting mussels into the system in the first place, which is going to be your best bet for overall long-term management and cost savings. So when golden mussel first arrived, we helped establish and set up a watercraft inspection program up at Lake Oroville. And we were involved every step of the way through this process, from program planning and logistics, such as siting the different facilities and acquisition of supplies, as well as overall staffing and management of that staff of about 50 to 80 watercraft inspectors, decontaminators, and seal checkers at any given point in time. And then we also supported outreach and educational support to the public while the program was running. In addition, we're also able to review and address invasion risk by the golden mussel by assessing the various pathways that the golden mussel can arrive through and site-specific suitability in terms of water quality characteristics. And then we can also provide guidance and creative engineering solutions to avoid getting mussels into your system in the first place. Furthermore, we have also supported the production of the CDFW required prevention plans that are required if you manage a water body that supports recreational activity. So when we move over to preparation, we highly recommend taking any steps possible, even if you don't necessarily have mussels in your system already that you know of. It's highly recommended to prepare for an invasion, because once mussels are in your system or facility, time is sort of the essence. And so this usually comes in the form of a comprehensive vulnerability assessment, which is going to look at the various vulnerabilities of invasion, as well as specific structural vulnerabilities that are unique to your system. And then it's going to produce feasible mitigations for your system based on the actual infrastructure and conditions that you have. And so having this in place is going to allow you to have a variety of kind of like break glass solutions in the event that you do find golden mussels in your system or facility. We've also supported NPDES monitoring or permitting, which we do recommend getting in advance of an actual invasion. That way you are able to quickly move into treatment rather than having to spend a bunch of time applying for that permit. We also provide engineering support in this area as well, with actually implementation of those different system retrofits and protective enhancements that would be advised or recommended based on the vulnerability assessment. And then we have also provided support to a number of water agencies with early detection monitoring through a variety of different methods, including deployment of settlement plates, as well as veliger detection through plankton tows. So in the scenario where you have golden mussels in your system already, we have also assisted with actual response to that invasion in a variety of different ways, mainly consisting of various treatment and golden mussel management support post-invasion. And so soon after we found golden mussels in California, we were involved in creating a mobile laboratory, or building out a mobile laboratory. And we've been managing a variety of research at this laboratory since, in an effort to understand our various feasible treatment methods for the species and how golden mussel responds to those various methods. going to focus a little bit on the copper studies that we've done so far. So what we're looking at here is a visual of the results of a handful of copper studies that we've done to date. So we're looking at days to 100% mortality on the y-axis, and then the different copper concentrations that have been tested on the x-axis, and the golden mussel studies are represented by the gold dots. And so a couple of the sort of big insights that we have found throughout this process is, first, that there's a very strong demonstrable relationship between temperature and treatment efficacy. So these 3 circled points represent 3 different studies that were done at 300 parts per billion copper as copper. And the studies that took a longer to see 100% mortality were conducted in the winter, whereas down towards the bottom, we see a much quicker mortality in during studies conducted in warmer water temperatures. In addition, we've also been able to show that treating at a super high dose, so we're looking at 500 compared to 1,000 parts per billion here, has very minimal effect. And so we've been able to kind of dial in the appropriate treatment doses and recommendations based on the timing and the specifics of the treatment location. So basically, that's all to say that this kind of puts us at the leading end of the research and the ongoing understanding of how to deal with this species. So in addition to that, we also provide support in coordination with various chemical applicators. So we have reviewed treatment plans to make sure they are in line with what we currently know about the current state of the science and what works best for treatment planning, as well as support with staging and treatment logistics. We are able to design and install injection systems for long-term treatment planning. And then we also provide efficacy monitoring. And so this looks like chemical sampling during a treatment to make sure that the correct dosage is being met, as well as mussel response monitoring in terms of deploying mussels, either tracking mortality during an ongoing treatment or tracking settlement during an ongoing treatment, depending on what the treatment goal is. And then we're able to do this because we have I have a scientific collecting permit that allows us to do this work. And so finally, we're also providing support on preparation of CDFW control plans, which are required if you have an invasion or found to have an invasion in your system. And so these are just a couple of the primary sort of leads within each of these various disciplines, including Stephen Burkholder, which I'm very happy to announce is now with Dudek and is present today to help answer any questions that you might have. Thank you all.
All right. Thank you so much, Valerie. And thank you to Jake and Katie for presenting today. We'll open the floor to any questions. Are there any questions? All right. If not, I've got a few questions. So this one is for the entire group. But let me interrupt that first. So can the presentations be shared by email? Sure. Just if the sponsors agree, please send them to me, and then we'll include that as an attachment along with our webinar recording. But back to the question. So tell us, this is for the group, but tell us more about the differences between your offered products and services and how potential customers can kind of decide how to select which is best for them.
I think Jake has to go first because prevention really is the first line of defense, and I think that's really the most important aspect of integrated pest management with invasive mussels.
Sure. Yeah. So I guess one of those, I guess, the biggest piece of it being how much traffic is coming to your launch. Are there other lakes within your region that are already infested? And what are those specific target species? So if you're not necessarily targeting zebra mussels or spiny water flea or something that's smaller, then you don't necessarily need to go with something that has the wayside, that has the air components. If it's more targeting with just macrophytes, then those other smaller units work just as good for those. So yeah, I think that that answers the question there.
Let me follow that up, Jake. So in the context of golden mussels, like what product lines would you offer or think would be appropriate?
Yeah, so in terms of the golden mussel, then ideally you would use the wayside versions. So you have that wet dry vacuum in order to suck up any water from your watercraft that might be harboring those invasives. And same thing within the air blower, making sure everything's as dry and clean as possible so that you're going to lower your risk of any kind of transfer.
All right, thank you. Caitlin?
Yeah, so we have two copper-based molluscicides, and as Stephen alluded to, Jake's products are kind of for the prevention and ours are for the response part of a management plan. So it really has to do with your system. Again, if you need anything NSF, then the obvious choice would be EarthTech QZ, but if not, then we can kind of discuss the pros and cons of using each as it applies to your system. But really after mussels are confirmed, or if you know that you have incoming veligers, is when you would bring in our products.
Okay. Could you kind of elaborate a little bit more on some of the things that kind of differentiate the two?
Sure. So the EarthTech QZ versus Natrix CA, the EarthTech QZ is a much more acidic formulation. That's kind of how they overcome that tendency to bind to hard water ions or TSS or anything like that in the water, whereas Natrix CA uses the chelated copper, so it's a lot less acidic. So if you're worried about aluminum corrosion or anything like that on your system's pipelines, then I would tend towards Natrix CA for that. If you're treating a stagnant water body and you want to target mussels in one area, maybe Natrix CA would be better for that because, like I mentioned, it's a very dense formulation. You can kind of target it where you want to keep it. It doesn't have the tendency to spread throughout the water like EarthTech QZ does. So maybe if you're trying to spread the product throughout the water and have limited application means to apply, then EarthTech QZ might be a better fit.
All right, thank you. Stephen.
And I think too, Caitlin, we've kind of explored it here and there with the different water agencies that you're working with, but the NSF certification difference between the two products.
Yes, absolutely.
Touch on to you. So if you're a drinking water agency, you might need to make sure you're using something that has that NSF certification, as opposed to if you're, in just like a habitat management or other type of setting.
Yep, precisely.
All right, Stephen, this question, doesn't apply to you as much, but how do your, if I were a potential customer, how would I decide what I need and what services I could benefit from?
Yeah, I really think, Valerie touched on it, and the main thing is what's my connection? What are my vulnerabilities? How am I going to have mussels introduced into my system? If I don't have them already, where are they coming from? How can I mitigate that? And then, if I do have mussels, where are my most critical showstopper locations? If you're a reservoir manager and you're generating hydropower and you need to have cooling water lines that stay cold so that your power plant doesn't overheat, that kind of small diameter piping would be a place to focus mitigation efforts on. So really, I think just understanding your water system, understanding vulnerabilities, create the focus for how you would respond.
All right, thank you. I see we have a hand up. This is for Chris Stransky.
Yeah, can you hear me okay?
Yep.
Yeah, can you hear me okay? Yeah.
Go ahead.
All right, great. Okay, good. Yeah, great discussion. I have sort of a two-part question. I guess one is, Valerie, you showed some pretty interesting and compelling data there for copper, and yeah, love the laboratory there. Interested to see more about how you're planning to use that in the future and also test other chemicals. The first part of the question is, how does the copper that you tested compare to the copper in the products that Caitlin indicated? Is there one to, is there similarity or are there differences? Because it didn't look like even at high concentrations you were getting complete effectiveness, and those are pretty high concentrations you were talking about, and that could be a real problem, not only just from the cost and maintenance, but just the potential for implications in surface waters if you're getting copper out there and you have the unintended consequences of copper building up, and not just copper, but other chemicals. So anyway, I'm just curious about that, specifically on copper. And then also like next steps, are you looking to do more tests with ozone and chlorine and things that may have more foolproof methods to actually get rid of them all? So.
Yeah, thanks for that. And then Stephen can probably speak to this a little bit more comprehensively, but I will just say that we have tested both of the products that Caitlin referenced, and so far we haven't seen any differences in efficacy. Both have the capability of reaching 100% mortality. What really changes the timing of 100% mortality is going to be the conditions, and usually that has to do with temperature or body condition, but we haven't fully assessed body condition yet. We just have a very strong hunch that has something to do with it. Then, in terms of other studies, we have looked at chlorine. We've looked at primarily low-dose chlorine, continuous and intermittent, to understand whether or not it can be used to prevent settlement. But and we have found that it does seem to prevent settlement at low doses on an intermittent regime. But then it carries sort of like certain concerns with downstream like drinking water issues. And then we're also looking into we're currently running potassium chloride studies in order to kind of pre-position ourselves to be able to use it as like a fish-friendly alternative. But yeah, we're looking at a suite of different chemicals in response.
Yeah. No, thanks for the answer. No, I mean, they're good questions, because I mean, at those doses of copper, you're going to be killing certain other species too. So it's not just the golden mussel you're going to take out. And so just like I said, particularly for surface water. So yeah, these guys are going to be a challenge with finding the right, approach and dose and what chemicals you can use without overdosing the system. Yeah. Thank you.
Yeah, no, great points, Chris. And I think one of the things we encountered with chlorine and our chlorine dosing is we're drawing water straight from the delta here, and there is all kinds of dissolved organic carbon, total organic carbon, and so our feed rates were like, to achieve a free residual chlorine of like 0.5 milligrams per liter, our feed rate was anywhere from 3.5 to 7 milligrams per liter. So the cost of chlorine has gone way up in the last 5 to 6 years. And so it was like, whoa, this cost per dosing has eclipsed what the copper molluscicide is, some of the feed rates. And then, the downstream issue of disinfection byproducts is huge, because a lot of state water project water that we're looking at here ends up as drinking water.
Yeah, great points. Yeah, for sure. Yeah.
And then Valerie touched on it a little bit, but yeah, what other molluscicides are we looking at and looking for? And, one of the big challenges we would have with high dose copper into the environment is, non-target effects. And so on the Snake River and some other settings, they've used potassium chloride effectively for resident mussel control. And it's been done in like vernal pools and kind of settings where we don't want to harm any fish. Feed rate, the application rates are quite high to achieve the mortality, and the exposure durations are somewhat on the longer side. But this is just like, it's a whole new dynamic for the concentration exposure time lens that we're looking at compared to the algae and the plants that we're used to managing. This is just like, different.
Indeed. Yeah, no, there's gonna be a lot of learning to figure this out. Yeah, thank you.
Yeah, thanks for the question, Chris. I see we have another hand up. David, do you want to go ahead? We'll address the chat questions afterwards.
Yeah, thank you. I was just responding to Chris's question or comments. Hey, Chris, and it sounded like you took away from the graph that even at some of the high concentrations of copper that they weren't getting to 100% mortality, but I think they were. The graph was showing how many days it took to get to 100% mortality. and just showing that it's, you know, faster at lower temps and slower at cold temps, and but they get to 100% mortality. And what we've really focused on a lot is trying to dial in what's optimal, you know, optimizing it. And if you use a lower concentration, it doesn't mean that you're necessarily not going to get to 100% mortality. You just have to be a little more patient. And if your concern is avoiding impacts on non-targets, then I'd say that's exactly what you should do, is, you know, use a lower dose, and it'll just take a little bit longer, but once you're there, you're there. And you can use a very low dose to prevent the mussels from reestablishing. If you have a system where there are no non-targets present, which does occur, you know, if it's going to a drinking water treatment plant, or other closed systems like fire suppression, there are no non-targets. Everything's going to be killed anyway. And so you could use a higher dose and get quicker results, you know, if you wanted to.
Right. Yeah. No, thanks for that clarification there too. Yep, that's important. The time. Yeah.
Yeah. I think some of the overall range finding we're doing is like, these aren't quite dresinids. They have a little bit more of a tolerance for both pollution and for metals, like copper. And so, you know, where are we needing to go to find, you know, that effective prevention dosage that would kill the veligers? You know, I think there's more research needed there. You know, how low can we go is the question that we need to answer if we're going to use these materials in a sustainable fashion in the future.
Yeah, thank you. Yeah.
To add on to that, I mean, I think the Delta and in general, it has very complex, you know, a lot of complexities. What are, you know, some of the water quality considerations when doing these types of treatments?
Yeah, I think, you know, as we've kind of, as Valerie alluded to, some of the temperature effect is really one of the most important aspects of water conditions that we're looking at. You know, they're cold-blooded organisms. Their metabolic rate is driven by the water temperature that they're immersed in. And, you know, we had one experiment we ran for maybe 55 days and didn't achieve full mortality in the winter. The water was just so cold, they never got to that lethal dose within our experimental window. And so that was telling. You know, also during the summer last year, we had a couple of flow through experiments we did where we achieved mortality much quicker than we thought we would. And we noticed when we looked at, you know, some of the veliger counts and veliger densities that it was really shortly post-spawn. And so some of the dresinid mussel research out of the Great Lakes has shown that there's this substantial advantage to treating the mussels after they've gone through the spawning event. They're spent. They've invested a lot of energy resources in that spawning activity. And so they've got some post-spawn susceptibility increase. And so when we're looking at managing these mussels effectively, I think these are all considerations we have to look at.
All right. Thank you so much. All right, let's go to the chat questions. So Stephen asked, are there any known examples of golden mussel eradication from a site they've colonized? Stephen Burkholder answers, not yet, not that I'm aware of. This question is from Aiden for SePRO. Do you have any studies or insight into differences in efficacy of either of your products between quagga mussels and the golden mussels? If so, what are the primary factors that are responsible for those differences, such as biology, temperature, concentration, water quality, etc.?
Yeah, so so far what we've seen with the golden mussel, the temperature has been a huge input and a huge factor and implication. As Stephen said as well, the biology post-spawning has been more effective than pre-spawning. As it compares to quagga, I think they're a little bit more resilient across the board in the rates that we've been treating them at. But I have mostly been involved in the golden mussel, and so I believe West Bishop may be on the call, and he may be able to speak more to the quagga mussel, as well as David Hammond.
All right. Give them a few seconds to respond if they're listening. Oh, go ahead. I see Algae Corner.
That's Dr. Bishop.
That's me, West Bishop. Yeah, and Dr. Hammond can chime in too. But yeah, there's quite a body of literature that exists with Earth Tech on Dresinid mussels, both quagga mussels and zebra mussels. There's a handful of sites we've done Natrix as well on quagga mussels quite effectively too. But yeah, Dr. Hammond's been involved with a lot of the descendant mussel research and peer review literature with that, so I'll let him jump in.
Yeah, so we were surprised to notice that there was a difference between zebra and quagga mussels. Quagga mussels are more susceptible to copper than zebras. They'll die faster in a lower dose than zebra mussels. Even though they colonize, they seem to be more adaptive than the zebra mussels. They'll go to deeper depths and, they'll kind of win out. Where both zebras and quaggas are present, the quaggas win. But they're more susceptible to copper than zebras. Now, golden mussels are just more robust in general. Whatever molluscicide you're using, you're going to need to use more of it to control golden mussels than you would need to control zebra or quagga mussels. They're just more tolerant of dirty water, polluted water, wider range of salinities. They're not as tolerant of cold temperatures, but they're more tolerant of warm temperatures, which is why they're, a worse problem in California. But those are some of the lessons that we've learned from talking with people in Brazil, where they've had them, for 20 years.
All right, thank you. Bill Taylor, I see your hands up. Go ahead.
You have to unmute yourself, Bill.
All right.
Does that one work?
Yes.
Yes.
Go ahead.
Oh, okay. I have a lot of experience with quaggas when they came into the state, and I have no experience with the goldens, but these guys are just so good at reproducing, and a single female can produce what, 40,000 eggs or something, and they love moving water because food just keeps coming past them, and I don't know if they can ever be eliminated from the system based on my experience. There's just too many of them. They're too good at what they do with the reproductive cycles. But does anyone know if any research is being done to look at a way to go after the reproductive system and, basically shut them down that way?
I think about a year ago, we had a presenter from Brazil talk about what is essentially amounts to genetic sterilization. So kind of breeding these golden mussels so they essentially become sterile. And if people are interested, we have that recording of our webinar posted on YouTube. But I think in the context of California, I just don't see that being a near-term solution. Okay, all right, let's move on. So Hal asks, CD3 is not decontamination. Is that correct?
Yeah, that's correct. CD3 is not decontamination. It's just the physical removal of the invasives themselves. And for the purposes of veligers, you don't necessarily need to have that decontamination. The decontamination, where CD3 lacks is with boats that have those zebra mussels or golden mussels encrusted onto the watercraft. Our equipment doesn't have the ability to get those off. And so those situations, you would need to have a decontamination system. But as far as the veligers go, that's an easy removal with either the air hose or using the wet dry vacuum.
Now, let me follow up with that. So is CD3 considering creating decontamination systems?
We are looking at potentially implementing some different features here in the future, but it won't be for at least another year or two.
All right, we'll have to stay tuned. All right, next question is from Stephen. What are the best methods for golden mussel detection pre-entry, like dogs sniffing boats? and in-lake eDNA monitored substrate visual, etc. This will be open for any of our sponsors to answer.
Yeah, I mean, I think the watercraft inspection, where you have people visually inspecting the boats is fantastic. If you can get the boat, the dogs, the mussel dogs, you know, they're also well respected and known to catch and encounter the mussels. Yeah, so I think that person who's trained in watercraft inspection is your best first line of defense pre-entry. And then, you know, once you get in lake, we have to look at different methods and target your system. So, you know, depending on kind of what your system is like, maybe it is some eDNA monitoring, villager tows are one of the more frequent methods that we use. So it can either be a vertical tow, if you have some substrates that you can plant around your boat docks, your launch station, where you would potentially have entry of golden mussels. You know, those would be a good kind of first canary in the coal mine for, do I have mussels colonizing here? Unfortunately, we haven't always seen the mussels settling where we want them to. We have settlement plates deployed in some locations where we know we've got mussels on bridge pylons and things like that, but they, for whatever reason, don't colonize the settlement plates. So, you know, I think it needs to be a combination of multiple ways of looking for these organisms to catch them as early as they show up, so you have some chance of an EDRR, early detection and rapid response type of approach.
All right, thank you. Anyone else want to chime in? Okay. All right, another question from Emmanuel. Oh, Bill, please go ahead.
I'm sorry. If some outfit has really critical structure involved, and they can access divers, it's one of the absolute best ways to go in and look around, especially where you have water moving through trash racks or anything like that that divers can get to. We found a quagga mussel, one of our divers' first dive on our intake structure in Havasu, and the mussels were there at about 1 to 2 mussels per square meter. 7 months later, they'd taken over the entire system, you know, hundreds of miles of aqueduct. So if that's available and you have critical infrastructure, that can be useful.
All right, thank you for that.
Great point, Bill. Yeah, and we've also utilized ROVs for that underwater looking where divers are incompatible with the site.
All right, next question is from Emmanuel. Are there case studies available when treating high flow open channels? This might be more geared for Caitlin.
We recently completed a treatment in the Arvin Edison Water Storage District irrigation system. They have a portion of open channel. Their main canal is open and concrete lined. We were mostly focusing on their closed lateral systems though. I mean, I can share some data with that from you. And I believe, Stephen, correct me if I'm wrong, I think the minimum or the maximum flow that they can settle at is 2 feet per second. So if you have constant high flow, it might not be much of an issue for you, but if that water does slow down, then of course it would be a problem.
All right. Yeah, thank you so much. And so if there are any additional notes the sponsors want to share, please email them over to me along with your presentations. Looks like we are out of questions, but I have one more for the three of us. So, you know, none of us have a crystal ball, but what do you think the near future holds for California and the golden mussel? What do you think are the biggest challenges the state faces, and how can your product or service help in addressing the biggest challenge?
I guess I can go first. I mean, obviously, I think that one of the biggest challenges is going to be the spread of it. It's already shown to be spreading very quickly throughout the state. And so as far as the prevention side of things goes, I think that we can offer a solution that helps to slow down those infestations and make sure that it's not being transferred by your weekend warriors and jumping from lake to lake.
And I think that following that, if you know you're past the prevention step, if you already have established adults, obviously we offer technologies to treat those adults as well as treating incoming villagers. If you have a flow system that the water's constantly introducing villagers or adults.
I don't know what to say about golden mussels. We're all in a whole new world with how connected the water systems are here in California.
Yeah.
Not really looking forward to seeing how much worse it's going to get based on what I've seen evolve in the last 18 months.
Do you think there's any source of optimism or hope where we are now?
Not joking. I'm not. Yeah, I mean, what optimism and hope I really think is just the communities of water agencies getting together and combining resources and information and sharing information amongst each other is really the only way where we're going to be able to, you know, create any sort of toehold against this new invader. You know, if it's going to be 5 times worse than it was last year and we move into some sort of asymptotic invasion curve growth here, like, you know, we'll have to keep our finger on the pulse, but we'll need everyone to be working together to try and manage this, you know, as regionally as possible.
Yeah. All right. Well, that concludes our final webinar of the year. I want to thank everyone for participating and for joining us today. Just a reminder, we have our annual conference in Davis this fall. And so we hope to see everyone there. And I just want to thank everyone and thank our sponsors again for presenting and giving us all very important information and making this very educational, but also helping to support our future professionals by contributing to our student scholarships. So thanks again, and we hope to see you in the fall. Take care.
Awesome. Thank you, guys. Yeah.
See you, Chris. Wow.
Nice job.
Ben,
Thanks
when's
for the opportunity.
for the conference?
So the conference is September 30th to October 2nd.
And then registration opens up probably next month, in the next month or so.
Yeah, we should have some announcements coming up soon, also along with hotel blocks and all that sort of stuff.
Excellent. Awesome. Well, thank you for hosting us today.
All right, thanks.
Bill, it was good to hear from you.
Yeah, we had a lot of experts on this panel, so that was nice to have.
We'll catch you guys later. Bye.
All right, see ya.